Within this talk, we'll highlight a portable and deployable analyzer for in situ continuous nitrate and nitrite monitoring within recirculating aquaculture systems, and the way in which the data can be, really can add value, and specifically the role the data has when considering optimization of water usage within the RAS setting. In the presentation, we'll touch on current issues or issues associated with other currently available technology, how aquamonitrix analyzers are different, the technology in which the analyzer is based upon, the benefits of continuous nitrite and nitrate monitoring within RAS, and also how continuous nitrite and nitrate measurement within RAS facilities can add value for not only biofilter startup and feeding and so on, but also optimization of water usage. So let's have a look at some other competitor technologies and the issues around those systems. So there's a lot of various other technologies available, such as ISEs, colorimetric based analyzers, and so on. There's a lot of different strategies available, but really UV probes are often considered a leading analyzer when considering in situ nitrate monitoring. But UV probes have big challenges, especially when considering RAS monitoring. The key issue is around the selectivity. There's no selectivity for nitrite and nitrate, but there's also challenges around interferences such as dissolved organic matter and so on. In addition, then fouling is also a big challenge when considering these probes in situ. Another key issue is salinity. Of course, within RAS, salinity can change. Not only you can have fresh RAS systems, but fully saline, but often within a freshwater RAS system, salinity can change over time. So salinity has a big impact on performance when using UV probes. And then another key issue is when considering crab and lab analysis. So this is quite typical, not just within aquaculture or RAS, but throughout the industry, various different industries. I hope we don't have to convince you of the limitations of grab and lab analysis. Really, when considering process control, grab sampling is not sufficient due to the poor temporal and spatial resolution which grab sampling delivers. But also, when monitoring grab samples, colorimetry is often used, and colorimetry can be impacted by varying salinity as well. So aquamonitrix then is different in that it combines rapid ion chromatography with patented UV LED based detection setup. Another key advantage of the system as well is the fact that the system uses a mobile phase of sodium chloride. By using sodium chloride as the mobile phase, it's essentially salinity independent. So the system can be deployed within a freshwater setting. The salinity can change over time, all the way to fully saline. There's no need to recalibrate, and accuracy is consistent and maintained. So within our last webinar, we went into this in a lot more detail. So we'll just touch on it here. But the key aspect of the aquamonitrix analyzers is the fact that through separation, in combination with our UV LED detection setup, we achieve selective detection of both nitrite and nitrate. To elaborate a little bit more on the direct UV analysis, as I mentioned, using a UV probe, you can't discriminate between nitrite and nitrate. As you can see, the absorption spectrum here, they essentially overlap. But the challenge, it gets a lot more challenging, especially in saline samples, because the absorbance of salinity essentially overlaps with the nitrite. So really difficult conditions when trying to monitor nitrite and nitrate using UV probes. We look at our system in a little bit more detail. Essentially, using rapid ion chromatography, we overcome those issues because we have the selectivity for nitrite and nitrate, and essentially the mobile phase passes through the system. Sample is introduced into the mobile phase. Everything passes into an anion exchange column. It enters into our UV LED detection system, and that allows for the direct absorbance of nitrite and nitrate. And we use it at a 235 nanometer wavelength LED, which allows for the direct absorbance of nitrite and nitrate. Essentially, what's happening behind the scenes within the system is chromatograms such as this one here are being generated. As you can see, really nicely resolved NO2 and NO3 peaks. The peak area of these peaks is automatically integrated, and that generates concentrations then, which is communicated back to the customer, and the customer has visibility of the concentrations of nitrite and nitrate in real time. In terms of analytical ranges, then, as you can see down here, for NO3, it's 0.6 all the way up to 500 milligrams per liter as NO3, and for nitrite, NO2, 0.05 all the way up to 100 milligrams per liter as NO2. So really broad ranges, depending on the application and the conditions in which we're analyzing. We can configure the system anywhere within these ranges. So it opens up a whole range of different applications. So that was just a little bit of a high-level overview of the system and how our system is different to currently available systems. But in terms of aquaculture and RAS, how does real-time accurate nitrite and nitrate concentrations add value? Well, by having this data, it allows for an improved understanding of biofilter at the start of phase and through production. It gives an improved understanding of the feeding in terms of maximum feeding, excess feeding, and so on. There's a greater understanding of water quality in general, which reduces the risk of mass mortalities. But in terms of low water usage, or the potential of reducing your water usage within RAS, it provides an improved understanding of the nitrogen waste status in the process, which basically informs the potential for reduction of water usage. So just to elaborate that on a bit further, in order to, working towards a reduction in water usage, a key consideration is, of course, the nitrogen cycle. So by having that real-time nitrite and nitrate data, it allows for an improved understanding of the status of the nitrogen cycle. So as we can see here within the nitrogen cycle, nitrite and nitrate are key parameters within this cycle. By having the real-time data on both these parameters, it provides the operator with a better understanding of the current status within their system. In addition to that, then as well, of course, when reducing your water, there's a potential for increasing your concentration of nitrogenous waste within the system, which can contribute to an increase in pollution levels within the final effluent. So having the real-time data assists with that. And also another big area, which is quite an exciting area within the general wastewater treatment sector, is nitrous oxide emissions. So we've had some customers where they're potentially down the road looking at, can they mitigate their nitrous oxide emissions within RAS? And as you can see, by having the real-time nitrite and nitrate data, that again gives good understanding and an improved status information on the potential for nitrous oxide emissions. So we just have a couple of examples of the real-time data which are being generated at some customer sites. This is essentially what our dashboard looks like. So on our IoT proprietary IoT platform, the customer has visibility of the nitrite and nitrate data in real time. But if we just look at the data, this customer in North America is using our system to well, towards the reduction of their water usage. And this is the data which they have available to them. It's early phases in their reduction of water design and so on, but by having this real-time data, they have the potential to do that. And you can see here a dilution event based on the high levels of nitrite and nitrate. They were able to take action and dilute. So having that real-time data is a big asset. Another example then as well. So you can view the data within our dashboard in real time, of course, but there's also a means of pulling down all of that data into whatever system, reporting system you need if necessary. So these two graphs were generated by pulling down that data. But this is for a fully saline final effluent RAS facility in the Netherlands. And again, we just wanted to highlight, despite the extremely challenging matrix, fully saline, really high levels of nitrogenous waste, the system can still deliver high levels of accuracy for both nitrite and nitrate. And they needed to carry out this analysis from a legislation perspective. This is just highlighting the real-time data which is generated from this facility. So that was just a quick overview of the system and some of the value which the system can add. Of course, we're very eager to have conversations and work with aquaculture experts and anyone who sees value in the data. So we welcome any questions, and feel free to get in contact if you have if you want to take any conversations further.
Thank you very much, Eoin. Very interesting presentation. It's a topic which is we've seen a lot of increase in interest over the last 6 to 9 months, particularly the low water use impacts, where tighter legislation and sustainability are becoming really key issues. I just wonder if anybody has any questions for either myself or for Eoin. Raise your hand. You can either talk or stick it into the comments box. While we're waiting for that to happen, I've got a couple of questions there. One of the things which we have seen with the move to low water use is the potential for higher nutrients concentrations in the final effluent. If you're using less water, there's a risk there that it could be stronger. But there's also other things in wastewater. You know, there might be oils, there might be all sorts of organic contaminants in there. What's the effect of things like varying organic loadings or varying sort of matrices on the accuracy of the instruments?
Yeah, that's a good point, Mike. So we touched on it briefly there in terms of the selectivity. So because we have our anion exchange separation within the system, and in combination with our specific wavelength LED, it's highly selective for nitrite and nitrate. Similar to the salinity question, the fact that we have the separation up front in combination with the matrix elimination technique that we use for sodium, so with the sodium chloride mobile phase, we maintain high levels of selectivity for nitrite and nitrate despite increasing organic matter. Turbidity is not an issue, things like that. So the typical challenges and problems that direct UV absorption measurements experience, we overcome by our anion separation, and also the fact that we're using the matrix elimination technique with the sodium chloride mobile phase.
Okay, we have a question popped up in the chat. Let me just have a quick read of that. This is a question from Thomas Mascara, asking really a question we have, I think, been asked before, but you can definitely address here, Eoin. It's asking about, does ammonia play a role at all in the monitoring? Is it beneficial to us to have an understanding of the ammonia levels, even if you're only, so based, I think there's a question around, is ammonia potential interference or does it affect it? But maybe you could expand on ammonia in general there.
Yeah, no, it's such an important question, and it's something that we've been working on, and we continue to work on very, very much. So on ideally, we're trying to integrate ammonium within the system, so that's in development. Of course, the ideal scenario is to have the real-time data on nitrite, nitrate, and ammonium within a single unit. That's our goal. Keep in mind the accuracy levels that we deliver for, or we aim to deliver for nitrite and nitrate, are really lab quality. So we didn't mention it within this presentation, but our system has an ISO accreditation for performance in the field. So really high levels of accuracy, 95% plus is what we aim for. So by having a really accurate levels of nitrite, nitrate, it still has huge amounts of value in terms of understanding the nitrogen cycle. Ideally, it would be fantastic to have ammonium as well. You have the complete picture, but that's in development right now. There's no commercially available system that can deliver that level of accuracy for ammonium, especially in combination with nitrite, nitrate. So I hope that answers your question, but the key point is, by having the high level of accuracy of nitrite and nitrate continuously, it most certainly gives a much better understanding of the status of the nitrogen cycle within a process.
Yeah. Well, I'll just add to that as well. We don't just work in the aquaculture sector. We work in wastewater treatments and drinking water, but there are a lot of analogies between waste water treatment and aquaculture, and the whole nitrification, denitrification cycle is certainly critical, and that's looking at where the nitrite is in that cycle gives us good understanding. We have another question coming through, Eoin. It's from Michael Beck. So we touched upon feeding regimes, and Michael's asking, how do you detect excess feeding, as mentioned in the presentation, using the nitrite and nitrate numbers? And I just wonder if you could maybe elaborate on some of the feedback we've had from clients where they have tied the feeding cycles into nitrite and nitrate. I think one of the graphs there was doing that. So I'll hand that back over to you. I think we've also done work with our Irish research station as well, where they've been tying in feeding. So I'll let you answer that one live, Eoin, for Michael. Yeah,
absolutely. So we have units deployed. Well, we had units deployed in the Marine Institute in Ireland. They have a research facility there. They were using our system for that purpose. We also had systems in Norway as well, who were using the real-time nitrite and nitrate data to inform feeding as well. From our side, the data doesn't mean a whole lot. We need the expertise, we need the aquaculture expertise to interpret the data and to translate it. Our job is to deliver the accurate, continuous real-time data, which that's our goal to do. Those partners and those customers that have been using that data, that was their interpretation of it. They were able to, an increase in, there was a diurnal pattern. I'm not sure if we have it in this. No, it wasn't. It's another case study that we have. It could have been on the last webinar, but it looks like a diurnal pattern. But essentially, the customer was saying that's actually, we were feeding at this time, the feed was being consumed, the nitrogen levels were changing accordingly. So you could actually, by looking at that trend, by that pattern, it correlated, or that there was a correlation with the rate of feeding and the rate of adding feed and so on. So it's from our side, it doesn't, as I said, the data doesn't mean much to us, but obviously with the aquaculture expertise, looking at the data, I mean, I'm sure you guys can interpret a huge amount more from the real-time data than we can, because aquaculture is not specifically our area of expertise.
One thing I can say as well is, if for you, Michael, if you're on our database, which you probably are, we can make. I've just made a note. We can just elaborate on what Eoin said there and get some data too. I think we have got the case study. So I'll just make a note that we send that out in an email to you as an attachment, so you can have a read of a bit more detail on that piece of work. So I've made a note of that. Anybody else with questions you'd like to put to Eoin? There's still some time on the webinar. We've got a few minutes left. But if there isn't anything else at the moment, what I will say is thank you first of all to Eoin for the presentation. I know from my own experience, putting these things together and getting them ready takes a lot of effort and time. So thank you very much for that. But also thanks to everybody who's joined us today on the call. We did try to get a little poll running, and it wasn't very successful. We were just wondering if we could reach out to you and say if we were going to choose a topic for the next webinar in terms of what would be of interest to everybody. One of the potential topics for another webinar was going to be the ever-changing environmental constraints on RAS systems. So we know that certain parts of the world are making it very, very tough from an effluent monitoring point of view. And we were going to look at how total N monitoring would be able to help in that. And then the other one was something which Eoin talked upon. We've seen an incredible increase in the attention being paid to greenhouse gas emissions, and with the growth of aquaculture systems and the sort of relation between nitrification, denitrification, greenhouse gases, we just wondered as well if that would be a topic which would be of interest. I'm not quite sure how we could do this, but maybe a real live raise of hands. I mean, if you could raise your hands if the effluent treatment would be more interesting, that would be quite good. You can see how many people raise hands. And then we'll give it a minute and see if we can raise hands for the greenhouse gas emissions. It's a good old-fashioned way of doing it. But we've got one raised hands for number 1 at the moment, which is cool. That's the only vote. Okay. We have 3 for the final effluent. We'll give that a minute to vote. Okay. One question and answer as well. While we're waiting for the votes to come through on that, another question here for you, Eoin. So the optimization of water consumption. Do we have a case study yet? That's a question from Raju, and I think Eoin can expand on the answer, but that's an ongoing piece of work we're doing with our one of our North American clients, where they are just running a reduced water usage system and taking the data from our analyzer to, first of all, they're in the measurement phase, so they're measuring nitrite, nitrate. The next thing will be to use that data to look at things like optimizing the rate of dilution, preventing nitrite and nitrate accumulation, trying to control feed rates, trying to control all of those to keep the nitrite and nitrate numbers within safe parameters. It's relatively early days in the case study, Raju, but we can certainly either take it offline with you and talk to you about how we could do that. If you have something you'd like to talk to us about, let us know. Or we can, as I think, we'll keep people up to date with regular newsletters anyway, is what I would say there. So if everybody could just put their hands down, and then we'll have a vote for who would like a presentation around nitrous oxide emissions. I can see the count. Does that answer your question, Raju? Is that okay? Okay, thank you. Okay, so I think we have a winner in terms of the topic for the next webinar. We'll do a case study and some work around the changing environmental legislation and how that can impact and how we can help with total N measurements. But for now, I will like to say thank you again to everybody for attending, to Eoin, and for Richard in the background, who's pulling all the levers and making the presentation work for us. This is an ongoing series, so watch out for an invitation to another one, probably towards the end of summer now, because hopefully many of us will be heading to the beaches and getting a well-earned holiday. So that's it really. Thank you very much from us. I'm going to end the webinar now. We will be doing follow-up with the questions and answers, and that's it. So have a great summer, everybody, and hopefully see you all again on a webinar soon. Thanks very much. Bye-bye.
Thanks, Mike. Bye-bye.
Okay, cheers now. Bye.